Hello student, welcome back again. In this part, we would like to discuss displacement, acceleration, velocity and their mathematical expressions along with an example. So let's begin. Let's start with the topic SHM equations. So first of all, we would like to discuss the equation of displacement. In this part, we will discuss about initial phase angle when it is phi. So it indicates the starting point in SHM where at t equal to 0. Means if any system executes its motion from rest, so we can draft its SHM equation. Like if phi equal to 0, the equation can be written as x is equal to a sine omega t. Because the standard equation we already discussed is x is equal to a sine omega t plus phi. So phi is the phase and omega t is the instant situation or instant location of the displacement. Now, where the starting point of SHM is at the equilibrium position O. So, at equilibrium position, actually the mean position where the displacement is considered to be 0. Now, we can write at t equal to 0, x is equal to positive a. So, mean we can say minus a positive a. Means we can say if at t equal to 0, the system is at extreme position having displacement a, so we can draft its equation as x is equal to a sine omega t plus phi, because already it is leading, already its motion is at maximum displacement. After some time we can say that phi the phase difference from the mean position is actually of pi by 2 radian. If it is lagging, it would have minus pi by 2. So the standard equation can be written as x is equal to a sine omega t plus pi by 2, where omega sine of theta plus pi by 2 is equal to cos of theta. That is x is equal to a cos omega t. What we discuss in this part? Actually, when the system is at extreme position and it starts its motion from extreme, so its equation can be x is equal to a cos omega t, and it will predict x cos function, a sinusoidal but a cos function. Means at t equal to 0, it is at maximum position and it is case of leading. Second part, we will discuss when t equal to 0, if it is in the second case, if it starts its motion from the compressed situation, if a spring is at compressed situation already, at t equal to 0, it is at compressed situation, its amplitude is x is equal to minus a. So what we will discuss in this part means we can say x is equal to omega t plus phi, and in this case, as the amplitude is minimum, that is minus a, so angle or the phase angle we are getting, that is equal to phi equal to 3 pi by 2. So it is the case of leading. So we can say x is equal to a sine omega t plus 3 pi by 2, and that can be equal to a sine omega t minus pi by 2, and that is equal to minus of a cos omega t, and it is a case of lagging by the phase of pi by 2. And we can write if the third case, if t equal to 0, second, the displacement is 0 and the either displacement along vertical direction, maybe along horizontal direction. We put the case for both the arbitrary, we can say abscissa or mantissa, like displacement along x-axis or displacement along y-axis. We got at mean position displacement is 0 but the velocity is maximum. So for this third case, we can say if it is at mean position, the velocity would be maximum, and at that case x is equal to a sine omega t plus minus phi, and that is equal to minus of a sine omega t, and it is the case of third equations. If we want to draft equation for velocity, we will say that from the definition of instantaneous velocity, velocity is actually rate of change of displacement at any time t. So what if we are given the equation of displacement as x is equal to a sine omega t plus y, we would like to differentiate it, and we are getting main equation as a omega cos omega t plus y, where phi is the phase of the velocity, whether it is leading or lagging. Now we can say if we want to draft the condition for maximum velocity, what we need to do? Cos omega t plus y is a trigonometric function, it need to be maximum. For this system to be maximum, this should be equal to 1. So we can say omega t plus phi should be equal to 0 degree. So we can say it is possible only when either theta or phi is 0 degree, means no phase difference, so it occurs at mean position. So at mean position, velocity is considered to be maximum, that is equal to a into omega. and that is it. Now, third case, we want to draft the relationship between velocity and displacement. So we are getting the equation as, if V is equal to, we can say, if V is equal to A omega cos omega t, cos omega t plus pi, and x is equal to a sin omega t plus pi, we would like to draft a mathematical equation like sin square theta plus cos square theta is equal to 1. We would like to find cos omega t plus theta is equal to 1 minus sin square omega t plus pi, and that is equal to v equal to omega under root of a square minus a square x square by a square, and that is equal to v equal to omega 1 minus x square by a. So finally we got a relationship v equal to omega a square minus x square. Or in another term we can say that v square upon omega square equal to a square minus x square. Or we can say that v square upon omega square plus x square is equal to a square. Or we can say v square upon a square into omega square plus x square upon a square is equal to 1. And it is equation of ellipse actually. So we can say, if at any moment we want to draft the equation of a velocity with a function of displacement, so that is v square upon a square into omega square plus x square upon a square, that is equal to 1. So what we did in this part actually, as we are given the velocity relationship as v equal to a omega cos omega t plus phi, we would like to change the phase of cos omega, so operator of cos to sine. We will recall a mathematical trigonometric equation, sin square theta plus cos square theta equal to 1, and cos of theta is equal to under root of 1 minus sin square theta. Or we can say we would like to draft it v equal to omega under root of a square minus a square x square by square, because we are given x by a equal to sin omega t plus y. So x square by a square equal to sin square omega t plus y. On substituting the corresponding values, we are getting v equal to a omega under root of 1 minus x square x by a whole square, and finally we get v is equal to omega under root of a square minus s square. So in another term we can say that this can be written as velocity at any time x, that is equal to omega under root of a square minus x square, and its unit is always meter per second. Now we would like to draft the equation for acceleration. So we can say acceleration can be represented as, so acceleration, it is just the instantaneous acceleration, or we can say it is just the tangential acceleration of the system, that can be equal to the rate of change of instantaneous or tangential velocity, so that a equal to dv by dt. On differentiating the equation of velocity as a omega cos omega t plus y, because we know that velocity equation already we calculated in the previous slide as a omega cos omega t plus y. So when we will differentiate cos function, we will get a sine function, and it would be acceleration is equal to minus of a into omega square sine omega t plus y. And already we know the mean of the given function as capital A for amplitude, omega is angular frequency, sine is a trigonometric operator, omega is again angular frequency, t is the time, and phi is the phase. So maximum acceleration, if we would like to calculate the equation for maximum displacement, and it is possible only when when a omega square sin omega t. So when this value sin omega t plus phi is maximum, so we have to calculate the condition for this sin omega t plus phi, or we can say omega t plus phi is equal to minus of pi by 2 or 3 pi by 2. So we will put minus of pi by 2, means either it is at extreme position, acceleration would be maximum, and at mean position and displacement is 0, it would have 0 acceleration. So we got acceleration a is equal to minus of omega square, where a is the maximum displacement. So in this part we discussed only the acceleration, that is just rate of change of velocity, instantaneous velocity of trigonometric or SHM equation, and on differentiating we are getting a function of acceleration, a function of x, that a as a function of time t is equal to minus of a omega square sine of omega t plus y, like that. So Ever in the case like we are given a mathematical equation, what we have to do in that case? So first of all, we would like, it is a function of y equal to a sine omega t plus b cos omega t. So we would like to draft this equation in a simple form, like resultant amplitude is r into sine of omega t plus y. So it should be the priority to convert that composite equation in a single function. On converting, we would like to differentiate that function with respect to time t to get velocity and acceleration term. On differentiating, we will get the equation. So acceleration A is equal to minus of a omega square, and if we want to know the maximum acceleration, we would like to put the displacement should be maximum, and it is possible when the displacement is at a 90 degree, or when theta is 90 degree or minus 90 degree, means it is where you know the condition already. We discussed this part, the case for maximum. So it is for theta is equal to pi by 2 or theta is equal to minus pi by 2. In the case of SHM, we discussed acceleration should be is directly proportional to the negative of displacement we discussed. Now, in the last part, that relationship between acceleration A and displacement x can be written as A equal to minus omega square into x. So x is the displacement. Already it is just a condition of simple harmonic equation where a degree of x should be equal to 1. So means the degree of x is, if degree of x is equal to 1, it is a case of SHM. If x is equal to 2, means n is equal to 2, we will say it is a case of double harmonic motion. And the SI unit for acceleration is meter per second square. Now, we would like to discuss a question based on this concept. A mass which hangs from the end of a vertical helical spring is in the SHM amplitude. So, amplitude means maximum displacement. We can say y max, that is equal to capital A, it is given as 2 centimeter. The 3 complete, okay, so means if there is a 3 complete, 1, 2, 3. So, total time required is 4 seconds. So we would like to know time required in 1 is equal to 4 by 3 second. So it is time, so we can say frequency is equal to 3 by 4 hertz. Now what we have to find, determine the acceleration of the mass at the equilibrium position. So at equilibrium position, displacement is always 0, because we know that if y is equal to a sine omega t, if it is the equation of displacement along vertical direction, so what, velocity is equal to a into omega into cos of omega t, and acceleration is equal to minus of a into omega square into sine of omega t. So what we are getting, a is equal to minus of omega square into y. At equilibrium position means point the mark sign. So at equilibrium position, y is always 0. So acceleration need to be 0, hence it should be have 0 answer. When the displacement is maximum, so displacement is maximum means the case of amplitude. So acceleration A is equal to minus of omega square into A, but when we want to know its magnitude, we have to mod it. So A equal to omega square is actually 2 pi f whole square into the amplitude. So A equal to 2 pi into frequency, so 2 into 3.14 multiplied by the frequency, that already we calculated 3 by 4 whole square of this function into the amplitude, that is 2 by 200 centimeter. So on solving this mathematical equation, we are getting 1.57. So 4.71 whole square into 2 by 100. So on solving this equation, we got A is equal to 4.71 whole square multiply by 0.02 centimeter, 0.2 meter per second square. So in this way we will get the acceleration, and what we did in this part, we must know the equation of maximum acceleration as a function of displacement. So displacement is maximum, it means it is the case of amplitude. So amplitude is equal to maximum displacement, A is equal to omega square into y. Omega is actually 2 pi f, 2 is constant, pi is constant, f is the frequency, that is 1 by t, and substituting the corresponding values we will get the answer, and on solving we will get the answer this part. Ask IITians brings you a very good opportunity to paste your questions regarding the subject. What you need to do? First of all, select www.askIITians.com, then choose Ask a Question link. After that, you will reflect a discussion board where you can post your questions. After that, you need to go for Select Category. If you want to paste a questions regarding electrostatic, choose the concerned link, then type your question. After typing the question, select Get Answer. Then you will find the answer of your question within 24 to 48 hours. In this part, we discussed about kinematics involved in simple harmonic motion. So in the next part, we will discuss about energy of a simple harmonic motion along with the graphical analysis of velocity and time, acceleration and time. So stay tuned with us.